This is pre-algebra lesson 9-2, angle relationships and parallel lines. An angle is a geometric figure formed by two rays sharing a common endpoint. Angles can be labeled by either 3 points or by the vertex. Angles must be labeled with 3 capital letters if the vertex can be shared by more than one angle. For example, here would be a nice little picture of an angle. The common endpoint is called the vertex. That's the point I just put on the angle. You can name an angle with just one capital letter, like N, if there are no other angles that could possibly be named by that figure. So I could name that angle angle N. I could also name it by 3 letters if I so choose to. I could label this angle CAT. If I was to name these, we have to give the angle symbol. This is angle N, and the angle over there is angle CAT. If you label an angle with 3 letters, the vertex must be in the middle. This letter must be in the middle. The vertex letter has to be in the middle. If it's labeled by 1 letter, it has to be the vertex letter that you label it with. If it's labeled by 3 letters, the vertex has to be in the middle of the label. Now, sometimes you have to label an angle with 3 letters. You don't have the choice of labeling it with only 1 letter. For example, in this particular case, we have 3 separate angles there. It would be very difficult to label it with just 1 letter. So we must label any of these angles with 3 letters, because you cannot label it with single letters. If I said angle O, you wouldn't know which angle O I am talking about. I could be talking about this angle O, or the giant angle O. Therefore, if we're going to talk about angle O, we better know which one it is. For example, we could label it angle HON. Then I'm positive that you're talking about this part of the angle right there. We've already said that the vertex is the common endpoint of the 2 rays of an angle, and you name an angle with its vertex if you're naming it by less than 1 point. Now we're going to talk about some specific types of angles. A right angle is an angle of 90 degrees. Okay? 90 degrees looks like this. You can either label it 90 degrees like so, or you can label it 90 degrees by putting a little square in the corner, because this square in the corner of the angle indicates that it is a symbol for 90 degrees. A 90-degree angle. Those are the types of angles you want your walls and your floors to be so that they don't fall down. An acute angle is an angle of less than 90 degrees. So once you know what a 90-degree angle is, you can understand what an acute angle is. An acute angle is a smaller angle, less than 90 degrees. Maybe perhaps this angle is 52 degrees. It would be an acute angle because it's less than 90 degrees. An obtuse angle is an angle greater than 90 degrees, but less than 180 degrees. An angle like this, maybe this angle is 138 degrees. That makes it an obtuse angle because it's larger than 90 degrees, but less than 180 degrees. A straight angle is an angle of 180 degrees, also known as a straight line. That's why it's called a straight angle. This is a straight angle. It could be that way, it could be this way. Could be diagonally. It's still a straight angle because it's 180 degrees. It's a straight line. Adjacent angles. Adjacent angles are angles that are next to each other and share a vertex and a side, but have no points in their interiors. Adjacent means next to. For instance, Mrs. Akowski and I are adjacent in classrooms because her back wall and my back wall are adjacent to each other. We share the same wall. Okay? Adjacent angles look something similar to this. They share a side. Okay? If I call this angle ABC, and this is angle ABD, angle ABC is adjacent to angle ABD. You'll notice they both share the same vertex and they share side AB. They share side AB in both cases. Vertical angles are angles formed by the intersection of two lines, like so. Vertical angles are opposite of each other and have the same measure. Many times, vertical angles are labeled with numbers versus letters. For example, I might say 1, 2, 3, and 4. I might number these angles 1, 2, 3, and 4. Angle 1 and angle 3 are vertical angles. Their vertexes have to touch. And they're always opposite of each other. They are not adjacent to each other. Angle 1 and angle 2 are adjacent angles, but angle 1 and angle 3 are vertical angles, which also means angle 2 and angle 4 are also vertical angles. As you can see, there's lots of vocabulary that you have to try to keep straight when you're working with geometric figures. Congruent angles are angles that have the same measure. We talked about congruency in previous lessons, and remember the symbol for congruency is an angle symbol, which with a squiggly line on top that looks like a sideways S. So if I have two angles that are the same measure, maybe this is 38 degrees, I have another angle over here, which is also 38 degrees, those would be considered to be congruent angles. One way to show people that angles are congruent without having to write the measure on them, right? If I said that this is angle B, and this is angle Z, I could say that angle B is congruent to angle Z. Right? But if I have a picture of an angle and I want to show that it's congruent to a different angle without actually having to write the degree measure in there, I simply do this. I put an arc symbol with a hash mark, and the same number of hash marks means that those angles are congruent. Whether it's one hash mark or 2 hash marks, we know that those angles are congruent. Even if they don't look congruent, in geometry, if they are marked congruent, they are congruent. Supplementary angles are two angles whose measures have a sum of 180 degrees. For example, I might do a 50-degree angle here and a 130-degree angle here. 50 plus 130 makes 180, so those would be supplementary angles. Supplementary angles can be separate angles, or they can be adjacent angles. For example, I can do this. I can say that this is 20 degrees, which makes this 160 degrees, and those are also supplementary angles. Okay. Complementary angles are two angles whose measures have a sum of 90 degrees. Okay. 90 degrees. Well, we might have a 20-degree angle here, and that's not very good 70-degree angle, is it? Let's try that again. And a 70-degree angle, and together those make 90 degrees. Same thing, you could have, let's make this one 50 degrees, and this one 40 degrees. They can be adjacent, or they can be separate, but they're still complementary if they add up to 90 degrees. Many times students have a difficult time remembering the difference between supplementary and complementary. Complementary, C, the letter C comes first in the alphabet, so it's a smaller angle measure, so it's 90. Supplementary is an S, S comes later in the alphabet, so it's a larger angle, so it's 180. Next we have a transversal. A transversal is a line that crosses two or more parallel lines. Okay, so the red line here is your transversal. Okay. The transversal is a line that crosses two or more parallel lines. It doesn't necessarily have to be parallel, but most often you'll deal with it when they are parallel. Now notice my transversal crossed two parallel lines. I'm going to mark these lines as being parallel. I talked about that earlier. So, and we labeled our angles 1, 2, 3, 4, 5, 6, 7, and 8. And we did that because we end up with specific types of angles when you have two parallel lines crossed by a transversal, you have some interesting angles here. One type of an angle is what we call a corresponding angle. A corresponding angle are pairs of angles that lie on the same side of the transversal and in the same general area. For example, angle 2 and angle 6 are a pair of corresponding angles. The reason being is they're both on the right side of the transversal and above the parallel line. Here's my parallel line, here's my transversal. Angle 2 is on the right side of the transversal and above the parallel line. Angle 6 is on the right side of the transversal and above the parallel line. So angle 2 and angle 6 are a pair of corresponding angles. Angle 3 and angle 7 are a pair of corresponding angles. Angle 1 and angle 5 are a pair of corresponding angles. And last but not least, angle 4 and angle 8 are a pair of corresponding angles. Remember, they come in pairs. Okay? You need to make sure you list them in pairs because they come in pairs. Next, we have alternate interior angles. Those are pairs of angles that lie on opposite sides of the transversal and between the parallel lines. It's pretty easy because alternate means opposite. Okay? If you alternate between hot and cold, that's the opposite, up and down, left and right. Interior means inside. So if I go back to my figure here, alternate interior angles are angles that are inside of your parallel lines. My blue lines are my parallel lines, so they have to be the angles that are between these two lines. And they have to be on opposite sides of the transversal. In other words, they make an X. So that would be angle 4 and 6 and pairs of angles 3 and 5. So there's two pairs here. Angles 4 and angle 6 are one pair, and angle 3 and angle 5 are the second pair. Last but not least, we have what we call alternate exterior angles, which is very similar to alternate interior angles. Alternate still means opposite. Doesn't change from one definition to the next. Exterior means outside. So now we have pairs of angles that lie on opposite sides of the transversal, but above and below the parallel lines because they're not between them anymore. They're now on the outside of them. So we're still looking to have a big giant X, but now we're doing a big giant X on the outside. This one to this one, this one to this one. So 2 and 8 and 1 and 7 are our pairs of alternate exterior angles. Angle 2 and angle 8 is one pair. Angle 1 and angle 7 is the other pair. Now the interesting thing about these angles is corresponding angles are congruent, alternate interior angles are congruent, and alternate exterior angles are congruent. What does that mean? That means simply this. I'm going to erase all this stuff I put on here. It means if angle 2 here is, let's say 60 degrees, that means its corresponding angle, angle 6, has to be 60 degrees. Which also means its alternate interior angle has to be 60 degrees. Since 4 and 6 are alternate interior angles, those would have to be 60 degrees. Okay. Alternate exterior angles have to be equal, 2 pairs with 8, so it would have to be 60 degrees. From there, you can find out every other angle in this figure, because we already know that angle 1 and angle 2 make a straight line. Right here, this is a straight line. And a straight line has to be 180 degrees, which means this angle has to be 120 degrees. Right, which means its alternate exterior angle has to be 120 degrees, which is down here. Okay, again, if angle 4 is 60, that means angle 3 has to be 120 as well. Its alternate interior angle has to be 120. So once you know that these angles, pairs of corresponding angles are congruent, pairs of alternate interior angles are congruent, and pairs of alternate exterior angles are congruent, I can give you 2 parallel lines, 1 transversal, 1 angle measurement, and you can find every other angle on that figure. Something else you need to be able to do is, we're going to add something to this. You have to be able to measure an angle. Let me add a blank page here. To measure an angle, you have to know how to do that with your protractor. This is very important. Many of you don't know how to use a protractor, so it's probably a good idea if you pay attention and kind of look going on with me. If I gave you an angle, and I'm going to draw it with the geometric shapes because it's probably a little bit better, because it's going to be a straighter line. There's one. There we go. I have an angle here. I'm going to lock this in place really quickly. And we're going to learn how to measure this. Now, I have a protractor tool right here. There's my protractor. Interestingly enough, if you notice, a protractor has two numbers. Okay, I've got numbers down here that are 0 and 180, and I've got numbers over here that are 0 and 180. Very simply put, when you use your protractor, the first thing you do is you put your protractor on the vertex of your angle. Okay, if you notice, that's not on my vertex. Here's where, see this little point right here, where the two things meet? We need to put that on our vertex. There we go. I have put that on the vertex. The next thing I need to do is make sure one side of my angle lies on the 0 line of my protractor. It doesn't matter which side. Okay. Now it lies in the 0 and 180 line. Obviously, we start counting from 0. So that's what I'm going to do. I'm going to start counting from 0. If I was to count up along this, I would go all the way to here. And if you read this, this is 10, 20, 30, 40. It's less than 50 degrees. It's a little over 45. It looks like it's 46 or 47 degrees. It's approximately 47 degrees. So I would say the measure of angle, we'll call this angle A, is approximately equal to 47 degrees. It's not 130 something. Because remember, it's an acute angle, so it has to be less than 90 degrees. So all you simply do is put your protractor so that the 0 point, the horizontal line down here, okay, the horizontal line on the bottom of your protractor, which is this line here where it lines up to the 0, and the vertical line at 90 degrees line up. And you'll notice here now I can sit here and move my protractor if I wanted to. Okay, so watch this. Let's move my protractor over here to my level of angle and see how close I was. Okay, I'm afraid your protractor doesn't do this, but mine does. Okay, if you do that, you can see that it's going to give me an angle measurement, isn't it? It's about 46 degrees is what it told me. I was off by 1. Not bad. You're going to be off a little bit when you measure an angle, just because you're human. Okay, we'll talk more about how to measure angles in class as well. All right, let's take a look at some angle relationships now that we know all the definitions. We're going to find the measure of angle 5, knowing that the measure of angle 8 is 35 degrees. Okay, so if the measure of angle 8 here is 35 degrees, what is the measure of angle 5? Well, we have vertical angles, and vertical angles have to be equal, because vertical angles are angles that are crossed by a straight line. Or you could look at it this way. You could say, oh, angle 7 and angle 8 make a straight line, so they have to equal 180 degrees. So if I take 180 and I subtract 35, that's going to give me the measure of angle 7. Okay? That would give me the measure of angle 7, which then I can find the measure of angle 5 if I forgot that vertical angles were equal. So if I take 135 and 180, and I subtract 35 from that, I'm going to get 145 degrees. That's going to be equal to angle 7. So we now know that this is 145 degrees. If I take 180 and subtract 145 degrees, I'm going to get back to 35 degrees, which is the measure of angle 8. So the measure of angle 8, measure of angle 5, not the measure of angle 8, excuse me there. Measure of angle 5. The measure of angle 5 is equal to the measure of angle 8, which is 35 degrees. Okay, which would make angle 6 have to be 145 degrees as well, because it still makes a straight line, doesn't it? This is a straight angle. So if I take 180 and subtract 35 degrees, I'm back to 145 degrees. Now I can find all the other missing angles. Angle 7, right here, is a corresponding angle to angle 3 over here, because it's on the right, it's below the parallel line and above the transversal, because here's my transversal right there. Okay? The red line is my transversal. Angle 7 is above the transversal and to the right side of the parallel line. So I need above the transversal to the right side of the parallel line. That corresponds to angle 3, which would be 145 degrees. We also have alternate exterior angles. Angle 7 is an alternate exterior angle to angle 2, and those have to be equal. So this would be 145 degrees. Moving along with alternate interior angles, angle 6 here is an alternate interior angle to angle 4. So angle 4 has to be 35 degrees for that reason. Or it could be 35 degrees because it makes a straight line with angle 2, which leaves us with angle 1, which also has to be 35 degrees. So we can find all our missing measurements once we know one of them. Let's look at something a bit more complicated. Let's look at figure 2 here. We're going to find the value of x. You might look at that and go, ew. But it's not really that bad. These are my parallel lines right here. Right here is my transversal. This is my transversal right here, which means I have some pairs of angles. This angle right here is a corresponding angle to this angle right there. And we already know that corresponding angles are equal. I already told you that. So if we know that corresponding angles are equal, then we know that 2x minus 45 has to be equal to x plus 30. Now we have a simple two-step equation that we need to solve, that we learned how to solve quite a while ago. So I will subtract x to get all my x's on the same side. That gives me x minus 45 equals 30. I will add 45 to both sides. And I now know that x equals 75. X equals 75. That is not the degree measure of the angle. I almost wrote that down even though it's not. X is 75. I can find the degree measure of the angle by adding 75 to whatever I have here. In case of this angle right here, 75 plus 30 is 105. I now know that that angle is 105 degrees. But it only asked me to find the value of x. X is 75. Our last figure. We're still going to find the value of x. If you notice, we have the square in the corner, meaning that this is a right angle, which means it's 90 degrees, which means that 3x minus 15 plus 2x plus 10 has to equal 90 degrees, because those two angles together make 90 degrees. Therefore, they have to equal 90. So if I simplify, 3x and 2x is 5x. Negative 15 and positive 10 is negative 5. That's going to equal 90. Add 5. Add 5. 5x equals 95. Divide by 5. 95 divided by 5 is 19. So the value of x is 19. As you can clearly see again, vocabulary is very critical when dealing with geometry. So you need to go over your vocabulary every night. I would suggest making flashcards. Put the definition on one side, the word on the other side. Quiz yourself every night. That way you can learn your vocabulary very quickly.